you can stay for the talk. It's okay. Stay. Eh,
Do you want me to ask people, hey, hey, come back?
yeah, say, come back, come back. yeah, anyway, so you can start the timer. yeah, it's sad that I have the last slot for the day. Anyway, so, well, this talk is about namespaces. Just a quick poll. How many of you actually code in Go? Wow, that's a lot. Okay. How many of you have worked on Linux kernel? When I say on, have you compiled your own Linux kernel ever? Okay, that's a fair bit of hands. How many of you are interested in this talk? Okay, fair enough. Cool. Thank you. Yeah. Just wanted to make sure that I'm not being redundant here. Yeah. So, who am I? I am someone who comes between you and dinner, so not an appetizer. So, anyway, my name is Piyush Varma. That's my Twitter handle. I've been using it for years. And yeah, that's it. Yeah. Well, so let's quickly start because we have too many slides and too little time. What's a namespace? A namespace is actually an attribute, property of the Linux kernel. What it allows is isolation across resources. The whole talk is about isolation. How do you want to isolate things? Because, well, although over years we have built, well, shared systems, multi-user systems, time-sharing systems, but our goal is always to isolate about what one process sees and runs and compared with the other ones running into the same system. So how do we achieve that? Is one good property called namespaces. What exactly are they? We'll go through the details and everything around it. And the talk will mostly run around certain code aspects which have been written especially in Golang. But the takeaway of the talk is more than just that code. Well, certainly you can do those things in Golang as well, but also to understand how those things work underneath and what are they meant for. Namespaces are actually very interesting for all the containers that are actually running around right now. And every time people say containers, they sell you this, the picture on the top. I definitely don't agree with that, because I mean, they're not that homogeneous. When most containers, like those are not throwaway containers. They're most like lunchbox in the down. Like that's what I call containers. Packaging of your own size, of your own format, and that's what you usually use, and throw them away as well. It's not costly to go throw them away. Imagine throwing away that entire ship of containers. Types of namespaces, quickly, is namespaces are categorized into mounts, UTS, IPC, PID, network, user, cgroup. Just use them as keywords right now. I'll explain them as I go into the talk. Where exactly do they exist? Well, they are everywhere in the system. They could be under your chair, in your phone, and but technically in a system you would see them. Am I visible because the background is sort of camouflaging me? Yellow head, black background. Anyway, so. Right. Or you could see a pair of trousers moving. Yeah. So, yeah. So the proc file system is where you actually find your namespaces. And this is that you pick up any PID in your process tree, and you try to look at the NS part of it, and you would see these namespaces. When the system starts, it starts with default namespaces for all of the aspects that we said, which is mount, net, PID, user, UTS, etc. And thereafter, you can fork and make a new one. But the key takeaway is that every process belongs to a namespace. A namespace can be forked from another namespace, but there is always a namespace, like running in your system. So, Syscall. How many of you have actually used Syscalls in Golang? Is this code readable for everybody at the back? Because I saw the monitors were really not appropriate. So I'll not go too much into the codes because the slides would be available anyway. So this is how you typically make a system call. So this is a system call which I'm making to get a PID. And the syntax is pretty similar. PID, you can ignore the next two error part and the other thing. And just make a syscall, pass in the syscall get PID, 0 argument, so you pass in 000, and what you get is actually the PID of it. This, why I'm showing this code is relevant because the next of the code samples will assume that you can make a system call. The first is UTS namespace. So do people know what UTS is? Okay, so I'll just, no. So this is just a small conversation that I copied from Stack Overflow, and so UTS is Unix time sharing, and by time sharing, I don't mean that things are sharing time, because that's what the guy thought it is about, that why are processes using the same time, they can use different time. It's about multi-users working on the same system. So a UTS namespace, starting a UTS namespace is as easy as this. You can ignore the line 3, 4, and 5 because I'm just adding a stud in, stud out, and stud error to it. Well, typically just make an exec command which will be executed. And the key property is that what I'm saying is cmd.sysproc attribute. And in here, I'm passing in a clone flag. A clone flag is, this is a system call where I say that, okay, clone underscore new UTS. And when I do that, the new process that is actually brought up will have its own UTS namespace. The relevance of UTS namespace, well, there are more, but if you really want to abstract it out, can be drilled down to a separate host name. Well, I know it hurts, right? Like so much talk for just a host name. So, but that it is. Like you just compile the code and you run it. So when I say meson 10 in square brackets, I'm inside the container, and the other part is on the host machine. So the meson 10 inside the square bracket, which is the container, I set a host name, which is hello. It prints out hello, and whereas on the root system, the host name is still the same. So this is how we have achieved sort of a UTS namespace isolation. There's a mistake here, the capital H, but that's a copy paste error by me. It's not what system will do for you. Like if you say host name small case hello, it will remain as that. User namespace. User namespace is pretty interesting because now you can achieve a sort of an isolation in the process that you are spinning. So the advantage of user namespace is that when you spin up a new process in a container internally, you want it to have root privileges, which is only inside that container without actually giving that process root privileges on the main system. Now, typically when you actually would spin up like for lack of a better word, Docker or something, and you have a process running inside it, which for that environment wants root privileges, it would have root privileges which are only constrained to that particular environment. So over here as well, same code. You can ignore the first, the 3 lines in the middle, which is stud in, stud out, stud error. And there is a clone flag, which is clone underscore new user. That's it. So you can actually define something which will run into a new user namespace. The impact of this is when I actually run this particular code. Now, when I land into the container and I say, who am I? It says nobody. Now, this is a problem here. Okay, one more thing about the talk is that every time you see this, it means that actually the problem is going to get a little more complicated. We are going one more level in our understanding of the system. And I assume everybody is familiar with this from their childhood. Yeah, so on the main system, when I say echo $UID, my current UID, which I ran the process with, was 1000. But when I run the same code which is spinning off a new user namespace, I do echo UID, I get nothing. And when I say who am I get nobody. Another interesting bit to note here is that all other namespaces other than the user namespace will require sudo privileges. But to create a new user namespace, you do not require a sudo privilege because you are technically forked off into something which doesn't have any mapping. And well, it's a not recognized user by the container anyway. That is not supposed to be there, or it's ignore that. So the thing about this part is now how do we solve this nobody thing? So what we're trying to do here is that we're making a bit of UID and GID mapping. When I spin up a new process, I would want to assign it a new UID and a GID. Now, when I assign it a new UID, I've just picked up a random number from one of the users which exists in my system, and adding that as a part of sysproc attribute is a part of the struct itself, where you give in a container ID, which is the ID that is it going to be mapped to. Host ID is what user is to be mapped to what ID. And size is, well, it's kind of redundant, but that's the syntax of it. One, as in like there's only one element in this array that I'm passing right now. And when I do when I run this, now who am I will actually give me a user called Grafana. Grafana is not hard-coded, just a user that I picked from my system. So what's really happening here is that when you actually spin up the new process, what you are saying is take this particular user ID of mine, and when it spins up in the next system, assign it assume this particular UID and GID. Now, because /etc/password was shared with the system, how do we isolate that? I'll cover that part as well. When it goes into the system and it picks up the UID, what it gets is that Grafana user. Yeah. So couple of helper functions, because I've been writing that stud in, stud out, and stdr over and over again. I've just wrapped it inside a make CMD function right now. What it does is it accepts a command and gives out the same command with just certain attributes overridden for it. The OS attributes are overridden just because when I actually play it from my own shell, I can have the standard in and standard out still working. So let's look at this one. Now, what I'm trying to do here is that before I spin up so I've created a new UTS. We learned that how a host name can be overridden by just a couple of function calls. But what I want, like in a standard practice, when a container runs, when you run your own Docker or anything like RKT or any such processes which we could be running internally, from security perspective, you would want to run certain amount of code before it gives out your terminal or the process is spawned. Now, in this particular case, let's say I want to start that shell program, but by that time, I want the host name to be set. Now, this is a problem because if I'm going to do a cmd.run here, that anything before that code is going to run on the host where the code is executing and not inside the container. So I need a way to actually send this code to be executed inside the container before that shell program is executed. So, well, that's another problem, gets slightly more complicated. And this is where I would like to introduce proc self-ex. This is a very interesting file on your directory on your Linux system. It's actually self-referential. And what I mean by self-referential is that I'm actually a fan of self-referential jokes, and like this one in particular. So what it typically means is that any process which is accessing proc self directory is the one who gets that. So if I were to say ls minus al proc self at that point actually refers to ls call itself and not any other process. So it is the current process which is executing that particular command. So you cannot execute that command on behalf of someone else, because the one who's spinning it is the one who would actually see it as proc self. And exe is just a fork exec there. So it basically just takes your own code, does a fork, makes an exec, replaces it. Now, before that happens, it gives us an opportunity to inject certain code that will run. Now, just appended a couple of helper functions there. The first function remains the same, which is make CMD. The timer is gone, by the way, so you might want to bring that back. There's another function which I have called is Rupa. All Indian people will get this because it's an inside matter now. And and on the right-hand side, all Western folks can catch me later. So there's a func main where I check whether it's is Rupa or not, and I execute an inner function. Otherwise, I execute the normal function. Now, so what it does is I'm going to wrap. So with just a couple of helper utilities. How do we use that? I'll show you. Yeah, so the same UTS namespace, which is that now earlier we were running a command which was bin/sh. We don't run that right now. We move that to the inner method. And the outer method, what it does is it just calls proc self exe and passes a hyphen Rupa argument to it. It's funny. So anyway, so when it does that, and the same method calls, the same binary would be called with the hyphen Rupa switch now, which tells the code that, hey, now I'm actually inside the child and not in the parent. It's kind of just a hack here. And credit to it actually goes to a Go coder called Liz Rice. I learned it at GopherCon UK in 2016. And the inner method is the one which actually does the job. Now, just before I make a command and I run it, I just say syscall.set hostname. Now, this code is actually going to run on the container and not on my machine. And this is where we'll hijack and we'll actually put in all our code to show the stuff happening. So anyway, so over here, I have a syscall.set hostname where I've just set in inner system. I've just set a hostname there and nothing else before the command is executed. Now, when we run it, when the hostname, the container comes up and I pass in a hostname command, it tells me that I'm actually in an inner system. You can save all the trouble of all this hacking and the unnecessary code which is anyway broken The Docker guys, which is now Moby, you can actually find this nifty module called reexec, and it has all the utilities inbuilt and a lot of error catching and a couple of other things as well. PID namespace. PID namespace is basically an isolation tree of the PID so that any process that you are running inside the container would actually only be limited to that and would have its own separate of PIDs. The process would still be visible because you're effectively on the same system. So, but the outside the host system would see it as a different process ID, whereas the one inside will actually see it as a different process ID, which means that process ID is actually not one integer at the kernel level, it's an array. So you can have you can have multiple as well, because there is one for the container which is running in, and there could be another process ID from a different view altogether. So if inside a container I run this and I say psax, you could see that the PID is 1 and the sleep process which I started has a PID 9, whereas when I see it from the same host, the host system, the same sleep would actually now be 12920, a different PID. This is, by the way, the desired output, but there are certain roadblocks that we'll run into. So PID namespace, same stuff that we've done earlier. We just say syscall.clone new PID, as simple as that. And when we started, I just print out os.getPID in the inner method. Now, what happens is that over here we started, and because it's the first process that started, it becomes the init process, and the inner code PID is actually 1, it works. However, there's a catch here. Now, when I do actually a psax, I see something else. Now, this is because the mount system is still shared. And how psax works is that it doesn't check the current listing of proc kernel, anywhere. All it has is a proc file system to list. So when you see /proc, it actually is shared between the host and the guest. So both of them are effectively seeing the exact same thing. One up again. Now we have to introduce something called the mount namespace. Mount namespace is designed to provide you isolation between the host and the guest so that they can work on different copies of the same file system and or can have their own mounts just to guarantee this isolation and solve the current problem that we ran into. So, well, this is just a different perspective of the file systems usually, because you effectively are looking at the same file system, but the guest would see it differently, whereas the host would see it differently as well. A mount namespace system is, namespace is same, as easy as that. You know, this code doesn't change. This stays with you all along. And you say syscall.clone _ new ns, and you can actually make a MNT namespace. However, let's just check it out. There's something going on here. Now, when I create a new mount namespace, what I would assume is that when I go inside my container and I actually do a new mount of a temp sys on an OK, it's just a bind. I can explain what bind is. Now, and I look at the propagations here. Inside the container, I see that temp sys has been mounted. Whereas when I come out on the host system and I do proc mounts, I see the same file system again. Now, this is not how it is supposed to be, because we were supposed to achieve isolation. Now, this is another problem. Now, the problem lies in how most Linux systems these days have been behaving. Now, if we look at the propagation level, I'll explain what propagation is, but just wanted to explain you what the problem is. So the propagation of the file system is in something called shared. If you look at the extreme right side, it just says shared. For those who cannot see, just trust me, it says shared. And then what it's supposed to be is actually supposed to be private. And again, as I said, I'll explain what this is, but this is how it is supposed to look like. Now, mount propagation, like why is this mount propagation important? Now, earlier when the whole file system namespace was implemented, what it started with was there is no crisp communication between the host and the guest, which is kind of okay, and that's how we wanted most of the times. But there are certain aspects when you want to share certain piece of information across containers or from the host to the guest. Imagine a new CD-ROM drive is available on the host and you want it available to the guest as well. What you would want to do is have a shared manner to do this, but it doesn't exist. And so hence in around 2006, a mount propagation property was introduced, which has 4 modes to it: slave, shared, private, and unbindable. Now, slave means that anything which is a slave, all changes that you do there are actually not going to go anywhere. And shared is anything that you do is going to reflect on both sides. Private is whatever you do is going to be absolutely independent. There is no communication at all. Unbindable is that you cannot do a mount bind on that particular file system directory. So if we now try to bring it the new thing, so what we need a way is to actually make that file system private on the host, so that before a namespace is created, I can, if I mark it as private, and when the new container comes up, because it is private, what I'm going to do, so private inherits private itself. So the new file system that will come out will be private, the mount. And what that would mean is that any changes that I do inside the container will not reflect outside. But again, this is how it's supposed to work, but it doesn't work that way. I'll just show right now in this particular command that I've added a new flag there called unshare flags, which is a syscall.clone new ns again. What it does, just come back to it. But once we do this, and I restart the exact same container, now instead of seeing the entire process tree, I'm only seeing 1, 6, and 7, the 3 processes where this is. So we have sort of achieved the MNT isolation here. Now, coming back to this ushare, the unshare flag, what this is that this was recently addressed in Golang 1.9, and I actually had, I saw this last night itself when I was writing this piece of code. And so what happens is that systemd is actually the culprit here. Every story has a villain, systemd here, and you would also understand why people actually hate systemd. I don't, I'm just saying that it is how it is. So when it starts, it mounts it as a shared file system rather than private. Like it was assumed everywhere that the systems would be mounted as private, but this actually makes it as shared. So this was the bug, which is 19661. And I like the last line. I'm pretty sure this was done to frustrate as many people as possible. He's actually cribbing about systemd, how he does it. So the way to overcome that is that they've added an unshare flag. Now, when you spin up a new process and you pass in your unshare flag and say clone new ns, what it does is assume it to actually just inject another piece of code in the same inner method where it mounts it with a private flag. And that's all it does. And one extra line of code that it does for you, because it was assumed that it would work that way, but it doesn't work that way. So if you're using 1.9 and above, all you have to do is just this. If you're using anything which is less than 1.9, you would have to mount it yourself. Yeah, so this is the 1.9 issue. There are other namespaces which probably lie outside the purview of my time window here, and which is an IPC, which is the inter-process communication things. There's a net, which sort of basically tells you that if there's a device which cannot be seen by others, and one physical device would only be available in one namespace, if you have to do any cross-communication sharing, you will have to do bridge networks and those kind of things. But those will have to be continued next year. Yeah. Thank you. I got slightly over a minute for questions.
Any questions?
Other than, where is the dinner?
Or other than, I need a drink. All right.
Cool, thank you.
All right, Piyush, thank you so much. Well, that does bring us to the close of day 1. The conference party. Yes, Samir? You have a question? Dude, you're the man. Piyush, you're back on stage because the party just got delayed. It's called an emergency question.
Why am I not able to see your face? Oh.
Piyush, just help me understand, in case of mount propagation, how is it done in case of heterogeneous file systems? For instance, you have an NTFS instance and you have a, say, for instance, ext4 or something of that sort.
Right. That would be orthogonal to this, right? Because once you have mounted it and a file system and it is available at a certain directory point, right? Let's call it /tmp/x. Now, what file system it is underneath is irrelevant because, well, the Linux system is only going to deal with directories here. Now, if I have to mount this, and this becomes available in my container as well, now I make another attribute to it. Like, assume this was not a container. Like, let's just forget that for a little. It was another process. If it was to write another file, like if I do a touch/tmp/hello/x, what does it do? It would just touch that file, right? Regardless of whether it's NTFS underneath or it's ext4 or btrfs or anything. Now, container is also another process. The only thing that changes is that what are the properties that it gets. Now, if it does another mount inside it on what it saw as a directory point, because for my container underneath, that directory point could actually be another altogether different the hard drive mounted as well. So these are just directories. And if they happen to translate to the same one, and there is a private, the mount which is happening, any changes that I make there would not be reflected outside, which means that this is actually going to be a different tree from here onwards. Does that answer your question? Could you please use a mic? I'm not able to hear you.
Yeah, so the isolation happens at the level of the VFS. So it doesn't matter what the underlying driver file system is.
Thank you for the support.
All right, so well,